Hello guys, today we will discuss one more problem based on branch and bound, that is sum of subset. Let us first discuss what is the problem statement is. Suppose we are given n distinct positive numbers, we can call it weights also, and we have to take subset of these numbers such that their total sum is exactly equals to n. Just consider this example. We have given 6 numbers with their weights 5, 10, 12, 13, 15, 18. We have to find out the subset such that their sum exactly equals to 30. Their m is equals to 30. So, we have to solve this problem using backtracking. Let us suppose if we explore all possibilities to find out the subsets, so what will be the scenario? Then we will see how using bounding function or applying constraint we can reduce the maximum exploration of this solution space tree. Just consider, suppose we have how many weights? We have 6 weights and we have to find out the sum is equals to 30. So what we can do, our solution space tree, like we can consider first weight or we can consider first weight or we can reject first weight. After considering first, we can consider second one or we can reject second one. After rejecting first, we can consider second or we can reject second. In this way, when we will explore all this solution space tree, we have 6 weights, so we'll have 7 levels. Except roots, we'll have 6 levels. So in that case, the complexity, total possibilities will be 2 to the power 6. So you can say it will be big O of 2 to the power n. So now we'll see how backtracking by applying bounding function can reduce these 2 to the power n complexity. So first of all, see what will be the bounding function. Here we will discuss about the all possibilities. Here bounding function will be sum of weight considered plus next weight. Their sum should be less than equals to m. It means, suppose we have considered the first object, the weight is 5. 5 is less than equals to 30. So we will select until this sum should be less than equals to 30. And the second one is sum of the weights plus remaining weight should be greater than equals to m. Then only we will explore that particular path. We will see these two constraints how we will apply on our solution space tree for rejecting some of the solution which never led us to the our final results. Just consider this example, the same example I am taking. We have 6 weights 5, 10, 12, 13, 15, 18. Initially we have not considered any of it and total sum is equals to 73. What does it mean? You can consider the first one is selected and second one representing remaining. Selected weights and remaining weights. Definitely it is the sum of the weights. Suppose we have selected first weight. So x1 is equals to 1. So the selected will be 5 and the remaining weight will be 73 minus 5, that is 68. Why we are not exploring this one? As our backtracking work is explore the solution space in DFS manner. That's why we are not exploring this one. Now, after considering one, apply the first bounding function of the constraint that the selected one should be less than equals to m. It is less than equals to m. Then we can select the second one also. x2 is equals to 1. So what is our x2 is 10. So now the selected will be 15 and remaining will be 58. 68 minus 10 will be 50. Now the same way we will select the third weight. Third weight is 12. Now selected is 27 and remaining is 46. Now still it is less than m. We will go for the fourth one and we will select the fourth one. The sum of the selected weight will be 38 and the remaining one will be 33. It is the 38 27 plus 13 is 40 and 46 minus 13 is 33. Now you can see our m was 30. As it is exceed to 30, we will just discard this. We will not explore this possibilities further. So that's why the bounding function is come into the picture. We will not explore further this tree. And as the concept of backfilling, we will go to the previous one and we will discard this x4 and see the situation 27, 33. Now after not selecting x4, we go for fifth weight. We will select fifth one, that is 15. This will be 42 and the remaining weight will be, remaining one will be 80. Again it exceed to what? 30. So we will again stop this solution or we will discard this one. And now we will go back to this and we will now not selecting x5. We will leaving x5. In that case we will left with 27 and 18. Now we will go with the sixth one, that is 18. So this will be 45 and remaining weight will be 0. Again it exceed to 30. This cannot be our solution. We will discard it. This was x6 is equals to 1. Now we will not consider x6 over here. So we will left with 27, 0. Now here you can see the second bounding function was from I is equals to 1 to k sum of wi xi. This is 27 plus sum of remaining from I is equals to k plus 1 to n should be greater than m. 27 plus 0 should be greater than or equals to 30. Now as remaining weight is 0, so we will not reach to 30. That's why we will discard this one also. Now you can see here we have not considered 6, we have not considered 5, we have not considered 4. Now we will go to the other option. Here in this case we will backtrack to x3 is equals to 1. We have considered x3. Now we will not consider x3. So if we will not consider 15 remain 15, we will discard x3. So we will subtract x3 over here. So it will remain 46. Now after considering 1, 2 and rejecting third, we will go for the option to consider x4. What is the x4? x4 is 30. So we will have 28 and what we have left with? We have left with 33. We consider fourth one. Again, as it is sum is less than 30, we will consider x5. Now, when we consider x5, x5 is 15. Again, 15 plus 28, that is 43, and this is 18. Again, we have exceed to 30. This cannot be our solution. So, we will discard it and we will go with backtrack to previous one and we will not consider x5. So if we will not consider x5, we will left with 28, 18. So after not considering x5, we will go to the next, exploring in DFS manner. Now we will select x6. When we select x6, it will be 16, that is 28 plus 16, it will be 46 and the remaining weight is 0. Again we will go with the same condition that it exceed to 30. We will not consider it. We will reject it for exploring next possibility. Again now we left with the 0. Apply the second bonding function. It cannot be lead to a solution. Backtrack to previous one. Here we have considered x4. Now we will explore other possibilities. By rejecting x4, we are not considering x4. After considering x1, x2, not considering x3, not considering x4, we have at the position where we have 15 and not considering x4, we will remain with 33. Now, after considering x1, x2, not considering x3, not considering x4, now we will consider x5. When we consider x5, x5 is what? 15. 15 plus 15, 30, and this is 18. 30 equals to 30, what we was looking for. This will be our one of the solution. So we have reached the solution by exploring this in DFS manner. So if you just see the solution space, you can see this is x1, this is x2, this is x3, this is x4, this is x5, this is x6. We have considered 1, we have considered 2, we have not considered third, we have not considered 4, we have considered 5th, no need of 6. So this will be our one of the solution. Now again see this. As backtracking talks about all possibilities, we have considered this one 1, 2 and 5. This lead to some 30. You can see some other solutions over here. This and this also lead to 30. The same way you can see these three. This is one of the another solutions for this particular problem. So if we explore further and explore all the possibilities by applying ordering function, we may have some other solutions also. This way backtracking reduces the complexity up to some extent from 2 to the power n to some less values. Thank you.